I think as we move further and further down technology rabbit hole and technology takes over, data is becoming more and more ubiquitous. It is everywhere, and the companies that are working on data are working towards taking a more scientific decisions, and that is not just companies that do it. It is also individuals who are working in different companies. I work in marketing. We take a lot of decisions based on data. We know that data is a big factor when it comes to investors looking at startups they want to invest in. One place where we don't talk about data-driven decisions in an everyday conversation is when it comes to picking out teams that represent countries with thousands and thousands and millions of people following brand names. So we want Virat Kohli to join the Indian cricket team, but there are data-backed decisions that make Virat Kohli enter the Indian cricket team, and his performance, which is also understood by data, is how he retains his space. I am very excited to announce and invite, Divya Pratap Singh. He is one of our instructors for our data analytics courses, and he's currently working at MPL. As more and more online gaming as more and more gaming companies are taking over, more and more people are getting onto it. How are data points understood? How are people able to swift through big, large number of data to take data-driven decisions is the basis of today's session. And just to keep it interesting, to make people more engaged, what we are going to do today is that we are going to be taking in a huge data set, and then Divya Pratap Singh is going to help us go through that data to figure out who are the Indian cricket 11 that should make the team. So if I could have Divya please join the stream. Divya, if you could turn on your camera and your mic. Divya, there seems to be a lag. If you could just
Trying it. Can you hear me now?
Yes, you are on. Thank you. Sorry, everyone. There seems to have been a small technical glitch. We were actually surprised it hasn't happened since morning. So, Divya, glad to have you. Just, we were just talking.
Yes.
We were just talking about the session, and I just wanted to take a second before you delve into it, so that you can tell us a little bit more about, what the session's going to be about, what are we going to be talking about. You've obviously shared a link with us, which we've shared with the audience here, which will help them download all the resources. If you are currently looking to take part in this session, there is a Google link in the chat which you can download, and that has the problem statement that Divya is going to work on today, and it also has the master data list, master data set to help you take this session forward. So Divya, if we can just take 5 minutes to talk about what is in data analytics these days, what is the session going to be about, and what are the opportunities of what people will see you do today.
Okay, what was the first question? Sorry, I missed you on that.
I asked you what is the opportunity in data science today.
So in terms of opportunities, I think we are living in an era where there are endless opportunities, right? Each and everyone, no matter which industry you pick, everyone is analyzing tons and tons of data, right? From even from the pricing of something as trivial as a cool drink to, let's say, something as huge as maybe an airplane or something, right? Even in a digital world where there are so many apps that each and everyone is using every day, there's like gigabytes and gigabytes of data that is being generated, and companies are using that very smartly to push new products, new features for the apps per se. So in terms of opportunities, this is like the best time if anyone wants to pursue a career in data analytics. Maybe if I talk about 10 years back, there were not so many opportunities, but right now, because so much advancement has happened, people have cracked new tools, people have cracked new techniques, and in fact, more and more data sources are coming in. So, I mean, this is a great time to actually be in the space.
Right. That's actually that is something that we were just speaking to one of our other panelists about as well. Could you tell us what is going to happen in today's session before we get into the practical of it all?
Yeah, so the session is essentially designed to give people a feel of how exactly you can play with data to come up with any actionable insights or any decisions per se, right? So we have a data which is about let's say 55 cricket players, and there's a problem statement attached to it, right? So in industry as well, what people would do is, let's say whosoever is attending this session tomorrow, they end up working for some companies, right? They would be given some data to work on, and there would be a problem statement attached to it, that how do you come to that story, how do you come to that conclusion, how do you analyze the data to come up with some meaningful information that can be used to derive some decisions. So we are going to go through, and essentially this is just to make sure that people who are attending this session, they get a feel of how industry is solving problems. And if I get into the nitty gritties of the data, so that is a like a uh, I would say two faceted data. One is where I have data about players, and the other is where I have data about venue, right? So in general, when you take even decisions in your real life, you will consider multiple aspects of it, right? So just to inculcate that feeling into the session as well, so we have a multifaceted data. I'll walk them through. I'll also kind of keep it interactive, where I'll ask that what do they think about it, what could be the decision over here. So we would, I would say, collaboratively work towards a solution. Obviously, it's a very open-ended problem that I have given over here. There's no one size fit all kind of solution to it, wherein I say, okay, these are the 10 things that I am going to do which should arrive at a perfect solution. Nothing like that. It is just for people to explore, people to learn that how do you actually, if let's say I dump a data in front of you and a problem statement, how do you approach it? So that is what I would try to put through in the session.
Awesome. So basically, what's going to happen is that we're going to look at 55 players, and we are going to find the best top 11 that we can do across positions. So it's not just, you can't just stack up your team with just batsmen, and you can't just stack it up with like all rounders. It has to be a mix. And before, again, the last thing that I want to know before we get into this is this in any way what an actual selector might be doing somewhere in a fancy boardroom with a other cricket experts? Is this anywhere even close to that?
So not sure about the selectors, but I think each and every team, each and every sports team these days has an analytics team, right? Even
Mhm.
if you have like, I think there was a web series on Amazon Prime which was, I don't know, something related to cricket. Do you remember the name? Even that they showed how actually teams function, right? So they actually have an analyst who would figure out, okay, this is the venue we are playing. It is a spin friendly track. How do you get to those numbers, right? There are always going to be statistics involved. So the selectors might not be looking at numbers these this closely, because there are people who are sitting at the top. If I compare this to a real life industry setup, so it is like the analyst would be working out the numbers, and let's say a VP or CEO somewhere is making the decision. So essentially, if I were to draw a parallel between these two scenarios, so what we are going to do now is come up with a recommendation or come up with uh, a conclusion, and then people somewhere at the top can obviously make a call. And in real life as well, I would say it would not completely be driven by statistics, right? There is always going to be, let's say, some brand value associated with it. Some players are too big to be kept out of team no matter how bad they're performing. So we'll not get into that, we'll not get into any emotions, we'll just keep exactly right. In data we believe, everything else is just story.
Yes, I work in marketing, so a lot of us believe in emotion, but now
Yeah.
we are moving towards, as you said, emotionless, number-driven decisions. I will leave you to it, Divya. I hope everybody attending this session takes back great learnings. I assure you, in my 10 years of experience, I have seen how valuable data-driven decisions are getting. This is going to be a good one. Cheers, Divya. Over to you, please.
Yeah, thanks, Pragun. So I'll just share my screen and
Mhm.
we'll get from there.
You can see the share button next to the camera
Yeah,
button.
yeah, I can. I'll just click on it. You folks can see my screen, type in the chat if you can. I have a Word document that is open. Okay, perfect. Let's start. So before we get into the nitty-gritties of data, let's just read through the problem statement, right? I hope you have gone through it. It is the link is in the chat where from you can download the resources, right? So first paragraph is just some build up towards the problem statement saying that you're a country that's crazy about cricket, right? And essentially the problem statement that we have at hand is we have data about players and the venue, and we have to select a team for a particular match, right? So you have data about 55 players, out of which you have to select a team of 11 players. I'll just increase the font size a bit, right? You have data about 55 players, out of which you have to select a team of 11 players, right? Out of that, and if there are some people in this session who are not familiar with cricket, so essentially what a cricket team is, they are going to be it's a 11 member team. There are going to be some people who would open the innings, right? The first and second batsman. Then there would be people who would follow them, right? And finally there might be a wicket keeper somewhere in between. There might be all rounders in the team, and towards the last there would be some bowlers, right? And when I say last, it means in terms of the batting order. If you were to rank your players from 1 to 11, it would start with opening batsmen, and then you would write down towards the bowlers, right? So a cricket team would be a fair mix of all of these different categories of players, right? And that is what we have to select, right? And there's whenever you solve a problem, there's always going to be a constraint around it, right? So the constraint is that the team you're going to select is going to play a 50 over match at a particular stadium, right? And why is this information important? Because if you follow cricket, you would know that it's a horses for courses kind of a setup, right? You cannot have the same set of 11 that would play. For example, if an Indian team is playing in India, you might have a different set of team. If you're playing abroad, you might have a different set of team, right? If there's a pitch per se which is more friendly towards, let's say, spinners, so you would want to have more spinners in your squad, right? On the other hand, there is a pitch which is more friendly towards your uh, fast bowler, so then you would probably want to consider a team which is heavy on the fast bowling side. Okay, so I have two sets of data. One is about 55 players and the other is about 20 matches. Okay, and now the problem statement is that you have to select a team of 11 players. Okay, everyone with me so far? Any questions so far? Okay, then I'll come to the right? So if you have a look at this Excel sheet, there are three tabs, right? One is player data, one is venue data, and the third is metadata. So does anyone want to take a guess in the chat box what is metadata? You might be hearing this term for the first time. Metadata. What is metadata? Anyone wants to take a guess in the chat? Okay, I'll explain. So metadata is nothing but data about data, right? So whenever you, let's say, start working for a company, data of data, that means to give a brief of data. Yes, that's absolutely right. So let's say you have a data which looks like this, right? So there are, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 kind of a columns, right? So if you are someone who is new to the team, who is seeing these kind of data for the first time, so typically every data comes with a data dictionary. And what is a data dictionary? Where you tell that how to use this data. Yeah, for example, I've listed down some variables about which I wanted to give you some information. Okay? So what we are going to do over the next few minutes is we would go through the data and try to understand what each and every variable means. Because a good analyst, this is what they do, right? First, they understand what the data is about. Unless you have a clear understanding of what the data is in front of you, you more often than not would not be able to work out a solution. Okay, so that is the first thing that we are going to do, right? First, generally, when I used to be an analyst, whenever I would get a data set, what I would do is I would try to print the first 5 rows of data, right? I would just try to look at four five rows, trying to see, okay, what is the kind of data that I have in front of me. Okay, so this looks like the first, which is column A, is a player ID, which is from 1 to 55, which is like a unique ID that I have assigned each player, right? In the real world, this could be player names, it could be a jersey number or whatever, right? So in general, that is how data looks like. There is going to be a unique identifier of each. In this case, it is player ID, right? Then there is a column known as player category, right? So what is player category? I'll come to it. Before I go there, I'm going to just use one Excel function which is called filter. Okay, so that I can filter my data, right? You can always Google the shortcut. This session is not about getting into all the 100% information that I can give you about Excel, but whatever things I am going to use, I'll keep on mentioning it, right? So right now I've just applied a filter. What is the use of a filter? A filter is used to have a quick look at data, right? For example, if I want to see what are all the possible values in column B, so I just click on this filter and it tells me all-rounder, batsman, bowler, and wicket-keeper, right? And now if I want to look at a specific data, for example, if I want to look at data of all-rounders only, so I can select all-rounder from here, and then I would have data about all-rounders only, right? And you can always go back and select all, so you would have uh, all players in the list, right? So essentially, there is a variable called player category, which means we have divided players into 4 categories. There's a batsman, there's a bowler, there's a wicket keeper, and there's an all-rounder. Okay. Next is player role, right? So how is player role different from a player category? Uh, Player role is basically a subdivision, right? For example, if a person is a bowler, that could be a fast bowler, that could be a spin bowler, right? If a person is a batsman, so that could be a opening batsman, it could be a middle order batsman, it could be a lower order batsman, right? So this is like a subcategory. Column B identifies the main category of player, column C identifies the subcategory of player. Okay. Then then we have a column known as ODI plays. ODI is one day international, which is nothing but the number of matches somebody has played. The next is total number of runs that somebody has scored. Next is what is the total number of 50 plus scores. The next is what is the total number of 100 plus scores. Basically, how many hundreds has that player had. Okay. Next is your batting average. I will come to it while discussing metadata. Then there's a column called batting strike rate, bowling average, bowling strike, and 5 wicket haul. So this is apart from the first two ones, this is like the numerical data you have, right, from column D to column L, and each of them has a certain significance to a player's profile, right? For example, batting average, right? Let's come to metadata. So what is batting average? Batting average is nothing but the average number of runs a player scores before he is dismissed, right? So essentially, number of runs scored by number of times the player has been dismissed in career in a particular kind of matches, right? So this attribute is important. Like people who watch cricket would obviously know a higher average means a better batsman, right? But for people who do not, this is for you, right? A higher average for a batsman means it is a good batsman. And there is a thing in data which is known as small sample bias, right? I'll explain what small sample bias is. So let's say there's a player who has played 100 matches, right? And let's say he has scored 3,000 runs, right? 100 matches, 3,000 runs. Okay. Let me write down the data here. Okay. 100 matches and 3,000 runs. Perfect. And so and let's say he has been dismissed in all the innings. So if I were to calculate the average for this person, it would be 30 runs per inning. On the other hand, there's another player who has played just 3 matches and he has, let's say, made 100 runs. Okay. So in this case, the average becomes 33.33, right? So if you were to take a decision on the basis of this data, right? So which one would you prefer? Let's say I call this A and I call this B, right? The left one is A and the right one is B. So which player would you pick? One has the average of 30 and the other one has the average of 33. Okay, I can see just a few people are typing 33. What about the rest of you? There's just 2 people. It's a A or B kind of a decision. It has to be one of either you'll pick 30 or 33. So this is what I meant by a small sample bias, right? So this player has only 3 matches, right? Scoring 30 runs consecutively for 100 matches is much better feat than scoring 100 runs in a total of 3 matches, right? If you have a very small data about anything, right, then you cannot use it to make statistically significant conclusions, right? If you have very limited information, right, if you have data about 3 matches only, right, that is very insignificant, right? It might be a fluke, but if a person is consistently performing over a longer period of time, so that is when you can have more faith in data, right? Anyways, so coming back, so this was the batting average. Bowling average is what is the number of runs a bowler spends, right? And we'll not get into all those details. If we can just understand a lower average for a bowler means that it is a better bowler, right? Similarly, batting strike rate, a higher batting strike rate means a better batsman, and a lower bowling strike rate means a better bowler. Okay, so this is all there is to know about your player data. Okay, next is the venue. Okay? So in venue data, I have again some fields, right? And these are like very intuitive, very easy to understand. First column is simply the match number from 1 to 20. Right? It is also a unique identity of every match. So whenever you see data in your career, right? If you pick up analytics, you would see that a good data is always unique at some level, right? Maybe if it is data about people, so every person would have, let's say, a unique number associated with them. In India, it could be, let's say, Aadhaar number, right? Or it could be a PAN card number, because no 2 people can have same Aadhaar or same PAN, right? At least that is what the understanding or the general belief is, right? Uh, so this is the match number with the unique ID being 1234. Next is runs scored in the first inning. So it is a ODI match that we are talking about. So one team would bat first and another team would bat second, right? So these are like the runs scored in first inning. Then there's a column called winning team. So winning team 2 means the team which bat second won the match, right? In this case, it would be the team which batted first won the match. So this is what is meant by 2 and 1. 1 means team who batted first won the match. 2 is team who batted second won the match. Okay. Next is wickets fallen in the first inning. So a game of cricket in an ODI has maximum 10 wickets. This is like out of 10, how many wickets fell in the first inning. Next is how many wickets fell in the second inning. Next is wickets taken by fast bowlers, and the next is wicket taken by spin bowlers, right? So these are all fairly easy to understand. I mean, there's nothing complicated over it. The first data set that we looked at was somewhat tricky. This is pretty straightforward. Okay. If you have any questions about data, please type it out. Okay, I'll move on then. So when you start working out the solution to this problem, right? I'm creating a new sheet. I'll call it, let's say, solution, right? So first you have to come up with a structure, right? So what is your team going to be, right? So typically, since you have to select 11 people, right? So first would obviously be an opening batsman, other would also be an opening batsman, right? Then maybe you have three middle order, then you have two lower middle order, right? And you can have bowler, 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 right? That is the basic structure you can give to your team, right? But then you have to think of some obviously there are constraints around the rules of the game, right, that you have to keep in mind. For example, there has to be one wicket keeper, right? So let's try to fit a wicket keeper somewhere here, right? Okay. Yeah. Then, in terms of making a team, you would always have to make a choice between whether you want to play more batsmen, whether you want to play more bowlers, whether you want to play some all rounders, right? So, this is like a rough structure of a team. Obviously, two opening batsmen you cannot negotiate. You need two specialist people who will open the batting, right? Similarly, there are going to be some specialist bowlers. So, the exact combination of the team will come later. But there's some surety that we have that at least we need two opening batsmen, right? Maybe like this is something which we know for sure shot, right? For example, we need maybe four bowlers, right? Right? There's one wicket keeper that we need for sure, okay? And the rest of the team combination we can figure out as we go ahead with the data, okay? So now, before I go ahead and actually start doing what this my class is named after, so why don't folks tell me in the chat what is a dashboard? Does anyone know what is a dashboard? Yes, insight view. Okay. So dashboard is nothing but a presentation of data in such a way so that it is very easy to consume, right? Uh, if I just show these many numbers to you, right, you might even get confused, and it is very difficult to make sense out of it, right? Dashboards are nothing but a better representation of data so that it is easy to consume, right? If you choose to take analytics as a career, what you would do is you would be making dashboards where typically your clients or your leaders, yeah, like people who are higher up the ladder, maybe it could be some VPs, it could be some directors, it could be some of your clients if you are in that kind of an organization. So dashboard is a very easy, very visually visually better representation of data, right? So let's try to make some dashboards out of it, right? And essentially the problem remains the same. I'll let's try to work it out piece by piece, right? Let's try to select two opening batsmen first, okay? Because that is something we obviously are going to have, okay? So first of all, if I go to the venue data, right? So from venue data, the data I have is about bowlers, right? Like there are two columns for bowlers, there are two columns for wickets, and there is only one column which is somewhat relevant to the batsman, which is the number of runs scored. On the basis of it, generally, so ODI is like a 300 ball game, right? So generally, the average score in an ODI, right? It is around, you can say, 275, or in some cases these days a lot of teams have started to score 300, right? So the first insight that I have is I simply took the average of, like, what is the average of team who has batted first in this ground scored, right? So the number that I'm looking at is 350. So the insight that I have from here is that it is a very high scoring kind of a ground, right? So you would need people who score fast, right? The insight that I have from here is, I can write it down here, the average first score is 350, right? So it's a high scoring round. So you need batsmen who can score fast, and maybe, not maybe, in fact, I mean, play long innings. Okay, that is the first insight that I have. So now let's get back, let's go to the player data. Okay, so now we are going to make our first dashboard of this session. Okay, so what I do is I select the entire data. Okay, and I go to the top. There's a button called insert. I click on it, and then there's a option called pivot chart. If you're using some older versions of Excel, so if the pivot chart is within pivot table only, here it is a separate entity. Okay, so I click on this pivot chart. uh, a new sheet has opened, right? Now let's see how do I make a dashboard out of it. My problem statement is that I need to select two opening batsmen. Okay, so over here, you would see there are four options, right? One is called filters, one is called access, one is legend, and another is values, right? Uh, with time, you'll all get to understand what they are, right? So filters is obviously, as the name suggests, used to filter out things, right? So for example, from player category, we only need, if I put player category in filters, from player category, I only need batsman, right? That is how I'm going to put my opening batsman. So I've selected batsman. Okay. Next was player role. Okay. Now within player role as well, there are multiple options, right? Somebody is a fast bowler plus batsman. What I'm looking for right now is an opening batsman because it's a specialist position, right? That is how we have envisioned our data. Okay. So let us see how, when I put player ID in, it could be player number 3 is, let's say, Virat Kohli, player number 10 is Sachin Tendulkar, 23 is somebody else, right? 45 could be Rohit Sharma, something like that. So these are, let's say, names of the players and or the ID of the player, right? And now I would start to visualize what are the matrices, right? What is the numbers that I would want to compare. So for a batsman, there are n number of things you have, right? You have the matches they have played, total runs they have scored, how many 100 plus scores they have. Uh, is there a good batting average or good batting strike rate, right? These three columns, bowling average, bowling strike rate, and 5 wicket all, these are not relevant when you are trying to select a batsman, right? So let's go back to our sheet, and let's say if I want to see how does batting average look like for these players, right? So if I would just select batting average and put it in values. Okay, so when I put it in values, automatically I get to see a chart. Okay, so now the good thing about dashboard is, right, how is dashboard different from any other form of data you can present, that you can play around with it, right? So that is the beauty of a dashboard. Okay, so let's go back and let's look at opening batsman only, right? I have just selected opening batsman. So so far you can clearly see, right? Player number 23 and player number 45, right? So player number 23 and 45 are clearly two players which have a very good average as compared to rest of the folks, right? This person is almost touching, like it is 57 and this one is 52, right? Uh, 23 and 45. So you can quickly go back to your data as well, right? So this is your batsman number 23, right? I'm just highlighting it. No, my Excel should not crash. Yeah, I have highlighted it. So you can see this is one player which has decent amount of matches played, right? Good 50s, 500s, pretty good average, and a very fast strike rate, right? So if I were to let's say plot strike rate as well, right? Let's say I have player data. What I do is, let's say I make another dashboard, right? I create another pivot chart. Okay, I should save this, otherwise it crashes and this is a very good tip to anyone who's aspiring to take a career in analytics or in fact in either form. Keep saving your work, right? Which is what I did just now. So I'll quickly create the filters again, right? Player category, player role, and player ID comes here, right? So now if I have applied no filters, you have data of entire 55 players. I quickly apply the filter, right? If let's say I apply a filter of a batsman, I apply the filter of a opening batsman, right? And now I put batting strike rate over here, right? So you would see most of the players 49 and similarly 53 is also pretty good strike rate, right? 163. 45 on the other hand is 142. Okay. So if you were to combine these two data points, so 23 looks like a clear winner to me, right? This player has the best average, right? Uh, from the data, we also looked at that he has 500 plus scores as well in 172 matches, right? So if you were to simply compare, right? If you were to simply compare, okay, does this data point look good enough? So what you can do is you can add another column over here, which in which you can say number of matches that a player takes to go to a 100 score, right? For example, Virat Kohli takes, let's say, 10 innings to score 100. On the other hand, some other player might take, let's say, 20 innings, right? So if that is a factor you want to put into, so you can obviously take that into account as well, right? But I, on the other hand, have very limited time. So because I have to form an entire team, so I'll skip that part. But that is also an additional layer of analysis that you can do. Okay. So far, like if I were to pick, I would say 23 and 45 is also, I would say, pretty good. 142 is not bad strike rate. So in our solution, let's put player number 23 and player number 45 as our opening batsman. Okay. Now there's one wicket keeper we have to select mandatorily, right? There's no way around other way around it. You have to have one wicket keeper. Okay. So now let's from our player data, let's select a wicket keeper. Right? Again, we'll create a dashboard. Okay. Player ID and player category. So in player, no, not player ID. Sorry. You have player category. In this, if you select wicket keeper, right? So you would right. I've selected a wicket keeper batsman, and now I'll have a look at what are my options, right? So there are only five players who can be a. There are only five players who can be a wicket keeper, right? That is what I have in front of me. So if I simply have to again calculate on the basis of batting average, right? So you see 20 and 40 are doing better, right? Their averages are close to 40. So wicket keepers are like traditionally in the game, they have never been specialist batsmen. Like batting is a additional quality generally they have. These days it has changed, of course, by the nature of the game has changed a lot. So these days even wicket keepers are scoring a lot of runs. But the data that I had designed, it is from a traditional point of view where your wicket keepers would traditionally bat lower down the order, and their averages would be slightly less because they would come towards far end of the innings, right? MSD is obviously an exception before somebody points that out to me. So let's say if there are two players, 20 and 40, right? I have looked at their averages, which are significantly better than the other two, right? So now between 20 and 40, because their averages are close, right? For player number 20, it is 41. And for player number 40 as well, it is also 41, right? So between 20 and player number 20 and player number 40, let's say I compare their strike rate as well, right? So it has 135, it has 136. So that is also pretty similar, right? So is there something else that we can look at, right? Let's say I look at 100 plus scores. So 20 has not, 40 on the other hand has 10 centuries, right? So this is a clear indicator that, okay, 40 is a much more experienced campaigner, right? If I go back and look at my data for player number, let's say 20 and 40, right? So player 20 has played 252 matches but has never scored a century, right? He has just scored 750. Player number 40, on the other hand, has scored 10 centuries in only 96 matches, right? So this looks like a very promising youngster to me, right? He is, in terms of average, matching a player, and this is not statistically significant, right? If anyone says that, hey, the initial example you gave us, you were comparing 3 versus 100, right? In this case, I'm comparing, let's say, 100 with 250. So both are significant, statistically significant numbers. So in this case, I would probably want to go with player number 40 as my wicketkeeper batsman, right? Because they are similar in average, similar in strike rate, and this person has had 10 centuries, right? So let's say in our solution, I'll fix my wicketkeeper as player number 40. Okay. Now next is where your subjectivities begin, right? For example, do you want to play 5 bowlers? Do you want to play 4 bowlers and 1 all-rounder, right? So what is the team combination you want to have, right? So this also there can be certain data inputs, but I do not have them in my data set, right? But I have created. There's always a limitation to the amount of information any data set can provide you, right? So in this case, we'll just go to our venue data and try to make some conclusion out of it, right? So one thing we clearly know is that this on this in this ground, uh, like the average first inning score is 350, right? So this is definitely a high scoring kind of a ground. So obviously you will need batsmen to score those runs, right? And whether you having 6 bowlers or 5 bowlers, right? In that is also a decision you would have to take, right? And if I were to compare in terms of the bowlers, right? So there are wickets which have been taken by fast bowlers and there are wickets which have been taken by spin bowlers, right? So if I just sum, right, the wickets that have been taken. So if I just write formula in here of sum, right? F2 F21, right? There are 146 versus 111, right? So there could be some bias in the sense maybe more fast bowlers were playing as compared to the spinners, right? And that is why they have taken more wickets. So that could be inherent bias in these numbers, what we are seeing right now. But whatever it is, you can clearly see that on this ground, fast bowlers have taken more wickets as compared to spinners, right? This is obviously I could have given you more data that okay, this is the economy of the bowler, right? I could have given you more data points around it that okay, this is the economy. I have bowling averages, but they are on the different slide. But from this, I can definitely make a conclusion that if I were to play 4 specialist bowlers, so maybe I can go with 3+1 kind of a setup where I can have 3 fast bowlers and I can have 1 spinner, right? Because this is what data is telling me. I cannot have 2 fast bowlers and 2 spinners, right? Because this is what data is telling me that fast bowlers are more successful in this ground. Okay. So now I go back to my solution, right? I update this thing at spin bowler. and then maybe I'll call this a fast bowler, a fast bowler, a fast bowler. Okay. So now we have to select just one spinner from the entire data that we have. Okay. So I go back to the player data. Yeah, I'll delete some of the older dashboards that I made, right? Otherwise, sometimes what happens is your Excel files become too heavy and your Excel crashes. So I'm deleting some of the old dashboards that I made. You can always delete them if you have to. So now we are on quest to find one spinner who is going to play in our squad, right? I again go to insert. I select a pivot chart, right? I have to select just one spinner. Okay. I'll again select player category. I'll again select player role. Then I'll have player ID, right? So now I have the data of the entire 55 players. I have to apply some filters that I'm looking at a bowler only, and within a bowler, I'm looking at a spin bowler only. Yeah, I'm looking for a specialist spinner, right? I'm looking at a specialist spinner. There are options of a spin bowler plus batsman, but that is an all-rounder. Okay, so I'm looking at a spin bowler, specialist spin bowler. Okay, so now I have only five options. And how do I compare spin bowlers? I have some attributes which are specific to bowlers, right? Which are your bowling average, bowling strike rate, and 5 wicket hauls. So I first have a look at bowling averages, right? So you remember me telling you in the beginning in the metadata that in batting averages we select the highest average because that is good. In bowling, it's the other way around. If a bowler has low average, it means that is a good bowler. So you can clearly see player number 6 has an average of 16, right? Player number 44 also has an average of 16.73. So these two players are pretty close. Let's try to make sure that both of them have played sufficient number of matches, right? So we go back to our player data and we will compare player number 6 and player number 44. Player number 6 has played 377 games and player number 44 has also played 492 games, right? So don't get into the nitty gritties that hey, who plays 492 games, right? This is just data that I've generated. This is not a real life data. I have not been tracking career profiles of people. It's just artificially made data which is made to resemble like a natural cricket data. Okay, so we can see that both of them have played statistically significant number of matches, and now we have compared their average. So both of their averages are close to 16, right? Now let's look at something else. Can we look at something else? uh, if we uncheck bowling average, if we look at bowling strike rate, right? In bowling strike rate, again, the lower the strike rate of a bowler, the better the bowler is, right? So how does it mean? So bowling strike rate is nothing but number of balls that a player takes to get a wicket, right? So this player number 6 takes a wicket every 30 balls. A player number 44 on the other hand takes, let's say, 9 more balls, right? It's 30, almost 39. So using this data, we can make a conclusion that okay, player number 6 has similar average and a better strike rate. Okay, you can also look at 5 wicket hauls, right, if that is something that matters to you. So in this case, player number 6 has 16 5 wicket hauls, and 5 wicket haul is nothing but the instance of a player taking 5 wickets in a match. So clearly, player number 6 is doing better than the other player 44 on all fronts. So now we go back to our solution and we have found our spinner, which is player number 6. Okay. Okay. So now we would be on our quest to find three specialist fast bowlers. Okay. Uh, what do? We again go back to our player data. We select it. We create another pivot chart and let's try to find out three fast bowlers. Okay. The process remains the same. Player category and player role, and we are looking at three specialist fast bowlers, right? So I select bowler in this filter. In player role, I would select specialist fast bowler. Okay, then let's see how many options do I have. So I have like 10 options to choose from, right? I have to select 3 bowlers out of these 10 bowlers. Okay, what do I do? Again, I have the same set of parameters, which is my bowling average, right? So if I were to pick the minima, right? If I were to pick the minima, so I think the minima is for player number 38, right? Then if I carefully look at it, next would be player number 51, right? And next would be player number 52, right? You can also validate this from the table on the left, right? If you were to search for minima, that would be 16.7, then 17, and then 19. So player number 38, 51, and 52. So in terms of average, these are my 3 best bowlers, okay? Now let me look at other parameters, right? Let's say I look at bowling strike rate. So again, we would look for the minimum bowling strike rate, right? And I would want to check for these 3 bowlers if I can find, right? So 38 has a strike rate of 34, which is not the minima. I think the minima is 32, which is for player number 34, right? So let's add player number 34 as well to our consideration, right? Because see, it can be subjective that what which variable do you give more weightage to? Do you give more weightage to average, or do you give more weightage to a strike rate? So I'm just putting it here. For player number 38, I think the strike rate is second lowest at 34, and for 52 as well, it is 34, right? So these two are doing good. Like these two are amongst the lower side of averages, right? 51 has a slightly higher average, which is 37. Okay, so we'll just say has a slightly higher average. Okay, now we'll go back and check what is it with player number 34, right? Can we can we select player number 34? I look at the bowling average. So player number 34 has a very high bowling average if you compare to it, right? So player number 34 has like one of the highest bowling average, right? 24 is one of the highest. There are only this is 24.48, 24.66, and 24.44. So it is amongst the highest bowling averages, right? This is not average. This is strike rate. Sorry, my bad. And this has one of the highest averages. Okay. Now, can I look at something else that can help me distinguish between 51 and 34, right? I can also look at maybe 5 wicket alls. So player number 34 has taken 6, while 52 has taken just 1, right? So this is also an additional information. 52 has 1 5 wicket haul. This one has 6 5 wicket hauls, right? So now, like you can keep on exploring more and more options, right? To that might actually help you take a better decision, right? So far we have looked at these bowlers from a purely bowler point of view. But these days you would have seen that a lot of teams are selecting bowlers who can bat as well, right? Who can have some sort of batting averages, who can contribute with the bat as well, right? So maybe if I start to look at the batting average of these players, okay, but can I get some edge for one player over another? So 34 has an average of 12, while 52 has 14. So not much difference, right? Like slightly better batting average we can write. Okay. As compared to 34. Is there anything else we can look at? One one very critical piece of information, if you want to consider your bowlers as batsmen, is what is their batting strike rate, right? Because typically, in high scoring matches, if bowlers have come to bat, right, so what happens is they would have to score very quickly. So we can look at the batting strike rate as well, right? So 34 is 65, 52 is 65 again. So nothing that we can make out of here, right? Has any one of them ever scored a 50? Let's see that. Okay, they have both scored 50s. He has scored 5, he has scored 4. Uh, did we miss anything? You can also look at what is the number of matches they have played, right? So 52 is a much more experienced bowler if you compare with 34, right? So 34 has played just 138 games and 52 has played 240 games, right? So 52 is a very experienced bowler. Okay. So now there's an additional information that you can have from here is you can also look at the number of matches that the other players are playing, right? For example, 38 and 52. So 38 appears to be again a very experienced bowler. 52 is somewhere in the middle, right? And 51 is a very experienced bowler. He has played like 389 matches, right? So over here, it is going to boil down to a very subjective decision, right? Because uh, like data wise, these 51 and 34 are pretty close, right? Except the fact that 34 is a very sort of less experienced bowler and 51 on the other hand is a much more experienced bowler, right? So this is where all the subjectivities creep in, right? You would not need more data to make this kind of decision. For example, what is the kind of attack you have, right? Maybe you have two right-handed bowlers and you need one left-handed bowler, so you would give preference to them. Maybe you have someone who has a very specific skill set. Maybe somebody bowls slower balls. Maybe so you would need more data to come up with decision. If we were to make a decision on the basis of whatever is in front of us, right? So I would say since 38 and 52, like 38 is a very experienced bowler and 51 has a the only thing bad against 34 is a slightly higher strike rate, but he compensates in a better batting average. So let's just select 51 for the purpose of our analysis, right? So in our solution, we'll write 38, 51, and 52. Okay. Okay. So now what we are left to select is your middle order batsman, like three middle order batsmen, and a lower order batsman, or an all rounder. Right. That is a choice we have to make. So now, if you were to look at the squad that we are choosing, right? If we were to look at the squad we are choosing, we have so far selected only four bowlers, right? So we would need someone who can bowl the next 10 overs, right? Because in ODI matches, you need at least five bowlers to finish an innings. So I don't think this team can afford to have a lower order batsman, right? I mean, this they can have a lower order batsman, but one all rounder is mandatory, right? That could play anywhere in the batting order, right? There are all rounders which open the innings as well, but for the sake of simplicity, let's just say we are placing our all rounder over here, okay? And we can have a lower middle order batsman, which is also called a finisher in games, right? So let's try to search for an all rounder, okay? Let's try to search for an all rounder. Again, I go to insert. I click on a pivot chart. Okay. His player category, his player role. I'm looking at all rounders. Now within all rounders, you can again have a choice, right? Like within an all rounder, you can have somebody who is a fast bowler and a batsman, right? You can have someone who is a spin bowler as a batsman, right? So what choice do you make? Since we know that pacers are more successful on this ground, so what we can do is maybe we can go with fast bowler plus batsman, right? That is my subcategory. Okay. Or in some cases, I mean, these are all dynamics that more data and some subjective knowledge can actually help select somebody a team. But if we are just looking at what we have in front of us, our data says that fast bowlers are more successful. So if we have to select an all-rounder, that has to be a fast bowling all-rounder, right? Now let's look at let's say their batting numbers, right? So in this, clearly batsman number 20, player number 27 stands out, right? In terms of average, if I were to rank, it would be player number 27, then player number 41, and then it would be player number 33, right? I'm not keeping the other two into consideration. The averages are pretty low, right? Now let's look at another number, which is, let's say, their batting strike rate. So clearly, player number 21 has a much better strike rate, right? The other two are not very low, but still, I mean, 111 versus the next best that we have is 108.5, which practically everyone is at 108, right? So player number 27 stands out in average as well, stands out in strike rate as well. Now, is there something else you would want to consider, right? Let's maybe we want to look at. Okay, first let's make sure that player number 27 is not statistically insignificant, right? Player number 27 has played sufficient number of matches. Okay. I think 376 is good enough number of matches. So the average can be trusted, batting strike rate can be trusted, right? Now I go back to my data, right? So this is batting. Now let's look at bowling numbers as well, right? Because ultimately, this person is an all-rounder. So in terms of bowling, and if you look at average, so the best bowler is bowler number 41, right? And after 32, we have 36, which is player number 17. And then we have 32, 36. Then we have 37, which is player number 27. So in bowling average, player number 41 stands out. Now let's look at bowling strike rate as in terms of bowling strike rate. Player number 27 has a very bad, right? If we were to point it out, so if we were to just look at that 27 was our option, so it has the highest bowling strike rate, right? So that's a very negative thing about this bowler. Then 41, which has a better average, better bowling average. If you like 41, has a good average, and by average I mean bowling average, but very high strike rate. So what do we do now? Maybe we look at some more information, right? something which has to give us a inclusive decision, right? Okay, is there someone who is an exceptional batsman? Is there someone with exceptionally good bowler, right? Because 27 is doing far in terms of batting, but in bowling, he has highest bowling strike rate, right? Or in the highest bowling strike rate and median bowling average, right? Let's see what else we have in our data, right? Maybe we look at 5 wicket hauls. 27 does not have anyone. 41 has 8 5 wicket hauls, right? That is also a good thing. Okay. What else do we have? We have looked at enough bowling. We looked at enough in terms of batting. Let's say 100 plus scores. 27 wins there, right? For 15 versus 100 plus scores 15 versus 12, right? We compare total number of runs scored. Again, both of them have scored very high number of runs, right? Both of them have scored close to 7,000 runs. So this is becoming a close contest between these two folks, right? Because they are like no, none of them is like picture perfect. Both of them have some good thing or some bad things about them, right? Now what do we do now, right? So if we start giving merit points, right? One good thing, one merit point, one bad thing, one demerit point, right? So for 27, the average and strike rate in batting is very good. Okay, we have not looked at strike rate of 41. Let's go back and look at that. Batting strike rate. What is the batting strike rate of 41? Okay, it was like 111 versus 108. So that is also not much different, right? So 41 is trending slightly behind 27 in terms of strike rate in average as well, but in bowling, it is a much better in terms of it is much better in terms of the bowling average as well as he has 5 8 wicket hauls, right? So I think this is one advantage that you can see. How would I come to that? Because bowling average is player leaking less number of runs for same amount of wickets, right? And you would see that these are very high scoring matches. So if you can have one all rounder in your team who is not leaking away runs, right? He's not. If you have to choose between two all rounders who take, let's say, the same number of wickets, so the one who is leaking less runs should be your priority. So basis that logic, we select player number 41 for our all rounder. Okay. So now we are left to figure out two middle order batsmen and one finisher, right? One lower middle order. Let's try to finish the. Let's try to find the lower middle order batsman, right? Again, we start a quest to find the finisher, right? Let's hope we find an MSD in here. Player category, player role. So player category again, we are looking at a specialist batsman, and that person should be a. What is the category? Do we have lower middle order here? Yeah, we have a lower order batsman, right? This is a very specialist position that we are trying to fill. And there are only 5 options available. Okay. Now let's look at in a lower order batsman, you would always Just give me 1 second. So in terms of batting strike rate, you can see that player number 29 outperforms them all. Right, rest of them are in 130s and 140s. So we'll just write in strike rate. We'll just write player number one. Sorry, player number 29. Right. Next, we can look at the batting average as well. Let's do this now. After 163, we have 142, which is player number 36. Right. In terms of strike rate. If we were to further this down, the rest of the three are like almost at the similar strike. Now let's compare averages. Yeah. So player number 5 has a better average than all of the rest. And then we have I think player number 29, which is at 41. Right. With this as right over here, if you were to compare this player number 29, very high strike rate, second highest average. Very high strike rate, second highest average. Right. You can also look at maybe first of all, let's just go back and make sure that both of them have played. If we are comparing, let's say player number 29 and player number 5, or player number 29 36, let's just go back and compare that they have played significant number. Right? We are comparing 29, 36, and 5. 5 has played 384 matches. Hey, sorry, I forgot to share my screen for a while. I hope you folks can see my screen now. Type yes in the chat if you can. Okay, perfect. So in the last 2-3 minutes, what I did was I just made another dashboard to find out a lower order batsman, right? Lower order specialist batsman. So I compared the batting strike rate, right? From which I found out that player number 29 is the best, and after 29 we have 36. Then what I did was I compared batting average, in which player number 5 was exceptionally high, and after that we had player number 29 at 41. Okay. Uh, then if you also wanted to look at if somebody has some 100 plus scores, so 5 has best average and most hundreds, right? And 29 has second highest number of hundreds, right? In terms of strike rate, we can also compare, since it looks like it's going to be a choice between player number 5 and player number 29. So player number 5 has a strike rate of 136, right? And it has 163. So that's a significantly different, right? There are the numbers 163 versus 136. I'll just write down their strike rates. Right? Uh, we have compared the 50s, we have compared. So now, if we were to make a call between these two, right? So for a lower order batsman, I think one of the most important things that teams are looking at that they can accelerate, right? They have a very high strike rate, and generally very successful finishers are able to accelerate. So that way, I think we can give more precedence to strike rate, right? So in those cases, 29 would make the cut. Okay. In a real life scenario, if we had more data about it, we could also look at can we find a finisher who can play some additional role. It could be a wicket keeper plus finisher kind of a setup, which MSD is, right? Or it could be a finisher plus a bowler kind of a setup in which players like Hardik Pandya or Venkatesh Iyer, those kind of players would fit in, right? So now we are left with the task to find two middle order batsmen, right? This is the last part of us trying to find a team. So I'll go back to the data. Okay, I'll leave this dashboard. Okay. Once again, I'll go ahead. I'll select it. Player category, the role, player ID, right? So now we are looking at a batsman and specifically two middle order batsmen, right? Who are like specialist batsmen. So we'll select middle order batsman. Again, the process remains the same. You compare batting averages, right? Get it down here. Right? So in terms of batting average, your player number 18, 21, and 39, right? We can go to the table and look at exact numbers. So 18 is 57.14285714. Okay, that's interesting. These two players have the exact same strike rate. 18, 21, and what was the third one? We are looking at 39. So 39 has 54. So 39 is obviously lesser than both of these. So we'll put 18, 21, and 39, right? These are our three best averages. So typically, if in your for your middle order batsmen, you would look at their ability to play long innings, right? So in those cases, how many 100+ scores they have becomes an important factor of consideration, right? Because if you are looking to play a squad on a ground that has an average score of 350 of first innings, so you'd want to have people who can stick around for longer, right? So in terms of hundreds, you can see obviously 39 is the best. 39 has 18 centuries, and after that, player number 18, which has 17 centuries, right? So not much difference. So let's start comparing the number 18 and 39. Also, we compare the number 21, right? Because these three seem to have made the cut so far. So best average, uh, 17 centuries. Second best average, 18 centuries. And 21 has the best average. And how many centuries does player number 21 have? That's like 11. Now we have looked at centuries. Now let's also look at strike rate, right? Because strike rates are also important when you are playing on grounds which have average score of 350. So we look at batting strike rate, right? And we'll compare our players 18, 39, and 21. Obviously, over here we have got a new and interesting entry, right? So 12, 39, and 35, right? I think it would be 12, 55, and then player number 39, right? So these three are the ones who have the highest strike rates, right? So now this again becomes a very objective, very not objective. This again becomes a very subjective, very experience driven decision, wherein you would want to see that in your middle order, would you want to have people who can play long innings at a fairly stable rate, or would you want explosive batsmen who do not have a great strike rate, right? They can come in, they can hit 30, 40 quick runs, and then they can get out, right? So in an ODI kind of a setup, middle order is typically given to people who are able to hold the inning for longer durations of time. So for a middle order batsman, average is a more important variable which holds more weightage in our decision as compared to a strike rate, right? So I would also compare strike rate among these three people, right? 18, 39, and 21. So 18, the 39 also has a fairly high strike rate, right? Second best average, 18 centuries, and second, not second, third highest. Right? Uh, then your 18 has, if we were to compare 18 and 21, 18 has 147 and 147, almost similar, right? Uh, so now we have analyzed quite a few things about our middle order batsmen, right? So in terms of average, let's just look at the average once more, right? So if I go ahead and look at the numbers, right? If I were to compare player number 18 is at 57, and your 39 is at 54, and your 21 is at again 57, right? So there's a difference of 3 points in terms of averages, right? 54 versus 57 is the decision that we have to take. So, if you have like followed cricket enough, if you were to make a trade-off of three average points, right? Somebody having an average of 54 in ODI and 57 in ODI. So both of these are class acts, right? These both of them can anchor the innings. But in them, if you are getting someone who has a relatively better strike rate, right? 54 and 57 is not so different, but if you compare their strike rates, right? If let's say it was 44 versus 57, then it would have been a no brainer kind of question. We would have gone with 57. We would have gone with person who had scored 57, right? But in this case, since they're pretty close, so 39 has to be the first middle order batsman that we choose, right? I mean, if we were choosing just one, so then 39 would have made the cut. Now, right, the second choice that we have to make, that is between player number 18 and player number 21, right? Both of them have same average, both of them have same strike rate, but player number 18 has 6 more centuries, right? So that means the ability of player number 18 to score for longer durations, play longer innings, is better as compared to player number 21. So that is going to be our last I would say decision making input, as in player number 18 and 21, they are same in all respects except the fact that player number 18 has made more centuries. Okay. So that way, if I were to go to my solution, I would put 39 as my and player number 18 as my number 4. So this is what my team would look like. So that is a fair point which somebody is pointing out, that 21 has more ODI matches than 39, right? But 39 clearly makes the cut, right? So 39 would be, let's say, a player of the profile of, let's say, ABD or Virat, right? So they would gain 126 is like having an average of 57 and 126 is no easy feat. If you're talking about 26 matches, we could have called it a fluke, right? I know the experience for the other player that I'm comparing with is more. 20 played more number of matches, but in terms of numbers, 30 clearly beats anyone in the team, right? 126 is not statistically significant. If it would have been, let's say, just 26 matches, then I would have called it that, okay, this is a very small flare, it may or may not continue. But 126 is statistically significant. our final team looks like. If you were to further make this problem interesting and take this much more closer to reality, then you could also have looked at the bowling performance of the batsman, right? If let's say, I think I created data in a very simplistic manner. I have not given data against batsmen. Let's say if I'm trying to take specialist batsmen, I have not given bowling points to them, right? But in a real world, your opening batsman might also be a part-time spinner, right? Or your middle order batsman could be, let's say, a Jack Scalise kind of a person who can very well give you 10 overs, right? So would be more of an all-rounder, but he can play in any team as a specialist batsman and a specialist bowler alone, right? So you can obviously complicate this data set more, and you can probably spend day or month or let's say 6 months trying to figure out a team, right? So that is anyways not a purpose of this session. The purpose was that you folks look at different variables, different decision making factors, different combinations of data. If let's say two things are, if let's say you have to make a decision and there are two variables that you're looking at, if both of them are giving you similar answers, so is there something else that you can use in your decision making logic to figure out that okay, is one thing better than the other or not? So overall, this is all I had for the session. I hope you all enjoyed. While the solution was worked out, right? If people love cricket, then they definitely would have, right? If there was some cricket specific nuances, so then I would say that you anyways have the data with you, right? You go back and read about it. If there's some terms that you do not understand about the game, you can obviously spend a couple of hours and then you can reattempt this exercise on your own. Okay. So Pragul, are you on the call? This is all I had to cover. Sure, I'll wait.
Sorry, something's gone awfully wrong with my laptop. So I'm joining from somewhere else. Divya, thank you. This has been really insightful. Even though I don't think I'll be picking the Indian cricket team anytime soon, I have learned things that I can apply to my work. Uh, thank you, everybody, for attending this session. We're going to be closing this room. If you have any questions, you can continue to share questions with us on our social media handles. It's at Masai School on YouTube, on Instagram, on Twitter, on LinkedIn, and I would request you all to come back to our main stage at 5 o'clock, where uh, we will join Ranvijay Singh in a candid conversation with Vinita Singh. So I hope to see you all there. Thank you so much, Divya. It's been a really, really insightful session.
Yeah, thank you so much, Pragun, for hosting me. I also enjoyed creating the problem and working it out. So thank you for hosting me. It's been a pleasure as well.
Absolutely. We're going to tap you in for more of these going forward. Cheers.
Yeah. Cheers, man. Bye.
Thanks, everyone.